Welcome, my dear students. Welcome to my video class. We will continue the atomic structure. I will go to the next topics. De Broglie wave equation. Okay. What is De Broglie equation? How he developed? He was a young scientist. He thought about dual behavior of matter. Before De Broglie, Planck introduced dual behavior of light. That is, light has particle as well as wave nature. Analogous to this, De Broglie said that every particle has, obviously it has particle nature and wave nature. For the light, particle nature was the benchmark, revolutionary. But for particle, De Broglie proved that it should have wave nature. And lambda is the wavelength. It is the wavelength associated with the movement of particles. Okay. Therefore, it is a very revolutionized idea that a particle and wave. What is the object between a particle and wave? How do you differentiate them? Imagine you are near a pond, water body. In your hand there is a small stone. The stone behaves like particle. Now you drop the stone into the pond, there will be water wave that spread the entire region of the pond. That is the wave. For us, particle and wave are two exclusive ideas. Stone is exactly different from wave. Stone, you can spot the point, the place where stone hit. You can spot it. But what is a wave? Wave is entire pond. That spread entire pond. That begin from that point and spread to the boundary of the pond. Therefore, particle is localized, wave is spreading. Now what De Broglie said that every object has both this property. Every object has both this property. They are hand in hand. That is what is De Broglie said. He proved an equation. We know we have two energy equations. E is equal to mc square. What is m? M is mass of the particle. Mass of the particle. C is the velocity of light or velocity of the particle with which it moving for time being. C is the velocity of the particle. Now you have another equation, E is equal to h nu. where nu is the frequency of light. Frequency of light. This E corresponds to the energy associated with the light. This E is the energy associated with the particle. Since our objects containing both behavior, particle nature and wave nature, therefore this is nothing but like this. Or mc square is equal to hc by lambda. C and C cancelled. That is mc is equal to h by lambda. What is mc? C is the velocity. Mass into velocity. That is nothing but momentum. Therefore, momentum is equal to h by lambda, or lambda is equal to h by p or h by mv. What is this lambda? This lambda is the wavelength associated with a moving particle. It's a wavelength associated with a moving particle. Therefore, this is the de Broglie equation. De Broglie equation. De Broglie equation. Lambda is equal to h by mv. Lambda is the wavelength associated with a moving particle. H is the Planck's constant. M is the mass of that particle. V is the velocity of the particle. Okay. Therefore, lambda is equal to h by mv, or lambda inversely proportional to mass. Now we know that kinetic energy is equal to half mv square. 2 into kinetic energy is equal to mv square. 2 into kinetic energy into m is equal to m square v square, or mv is equal to square root of 2 into kinetic energy into m. Therefore, lambda is equal to, we have another equation, h by square root of 2 into kinetic energy into m. It is also inversely proportional to kinetic energy. Okay. Now, we have another equation. Lambda is equal to h by 2 square root of 2 into m into kinetic energy in electron volt. How do you get how do your electron gets the kinetic energy? By applying the electron volt. When you apply the electron volt, your electron will get the kinetic energy. Okay. Now, m is the mass of electron, that is 9.1 into 10 raised to minus 31 kilogram, is 1.6 into 10 raised to minus 19 coulomb. H is equal to 6.6 into 10 raised to minus 34 joule second. Therefore, when you apply all this value, lambda is equal to square root of 150 divided by volt. Therefore, these are the different equations for lambda. You remember these things. What is the lambda? Wavelength associated with a moving particle. Suppose I throw a stone. A stone is moving. There is a wave associated with the stone. We cannot see that, but there is. Cricket ball. When you ball, the moving ball is associated with a wave. A moving bus associated with a wave. A moving train associated with a wave. A moving aeroplane associated with a wave. Okay? Yes, but this wave and wavelength will be significant when their mass is very low, because lambda is inversely proportional to mass. Okay, lambda is equal to h by mv. It is inversely proportional to wavelength. When mass is very less, Okay, suppose our electron 6.6 into 10 raised to minus 34 joule second. Suppose 9 into 10 raised to minus 31 kilogram into our electron moving with a velocity 10 raised to 2. Suppose 10 raised to 2. 100 meter per second. Now you just 6.6 into 10 raised to minus 34 plus 31 minus 2 all divided by 9. Minus 36 plus 31, you will have minus 5. Okay, now 6.6 into 10 raised to minus 5 divided by 9. This is 66 into 10 raised to minus 6 divided by 9. Okay, this is how will you do this? Seven 63 3. Okay, almost. It goes on. Therefore, 7.3 into 10 raised to minus 6 meter wavelength. Okay, that is pointer. If you make it to centimeter, 7.3 into 10 raised to minus 4 centimeter or 0.73 into 10 raised to minus 3 centimeter. An electron, suppose an electron moving with 100 meter per second velocity. This much is the its wavelength. It's not negligible. Now, suppose it moves in light, speed of the light. Suppose electron is moving with the speed of light. Here what happened? Here it will be minus 8. Okay. This value will be changed. But you know, this value will be significant. This is the wavelength of an electron. This is the wavelength of an electron. Look at this is the value of wavelength of an electron when it moves with 10 raised to minus 2. 10 raised to 10 raised to 2. What is the radius of an atom? Radius of an atom is 0.53 angstrom or 0.53 into 10 raised to 10 minus 10. Now you take the ratio. Radius of an atom or your wavelength of an electron 7.3 into 10 raised to minus 6 and radius of an atom. This is wavelength, this is radius. 0.53 into 10 raised to minus 10. You know what happened? Wavelength is by radius is equal to 0.73 into 10 raised to minus 6 divided by 0.53 into plus 10. Plus 10. Suppose it is, when you do that, 0.5 something into 10 raised to 4. Or okay, wavelength is equal to, by R is equal to, even if you neglect it, you will get 10 raised to 3. That is, lambda is equal to 1000 times of radius of an atom. It's an average calculation. What is the meaning? The wavelength associated with an electron is 1000 times greater than radius of an atom. Rough calculation. But It is too much significant. Therefore, what I am going to tell you, in the case of an electron, the wavelength associated with an electron is not insignificant. They are very much significant. Fine. But when you calculate a wavelength associated with a electron, cricket ball or football, that will be so insignificant when you compare size of the cricket ball. You can do that calculation. When you compare the size of the cricket ball or football, and wavelength associated with them will be so insignificant. But in the case of electron, that is not insignificant. That is too significant. That is the difference between wavelength associated with the electron and wavelength associated with the particles. This is what is called the de Broglie wavelengths. Okay, if you have any doubts, you can solve that. You just I give you a calculation. Calculate wavelength of a moving cricket ball with velocity 100 kilometer per second. The mass of ball is 0.15 kilogram. Okay. If radius of ball is 7 centimeter, compare lambda by radius. You compare it, compares. You can see how much it will be insignificant. Okay, thank you for watching.